Section 3.2, we're talking about measures of center, and I'm pretty sure you're familiar with all the words in that section. You probably would have done fine on the reading quiz even without my template. But I have something for you to think about for a second. This has nothing to do with the test you just took. It's made up. Group A consists of 5 students who took a test. Their scores are 70, 70, 70, 70, and 70. What's the mean score of Group A? 70. You add all 5 70s and divide by 5, you're going to get 70. Group B consists of 5 students who took a test. Their scores are 85, 85, 85, 85, and 10. Guess what their mean score is? You could add it up real quickly. This is 170 and that's 170, so that's 340, and 10 is 350 divided by 5 again. Their mean is 70 as well. And then Group C consists of 5 students who took a test. Their scores are 70, 80, 80, 60, and 60. Guess what their mean score is? Also 70. Which group would you say did the best? They all have a mean of 70, but you know, if you're the teacher of these 3 groups, which group are you going to be the happiest with? All right, consistency might be a good thing, unless it's consistently bad, and then consistent's not a good thing. Consistency can be good sometimes. Anybody have a different feeling about which group you would be most proud of? I think Group B is probably the one I would be most proud of, and I'd just write this guy off as a knucklehead. You know, the other 4 did great. So obviously it was a fair test. It wasn't a difficult test. 4 out of 5 of them made 85s, and this one just showed up to take the test high or something. So it's debatable. It's debatable. Mean is not always the best measure of center to represent how a group actually did, because all 3 groups had the exact same mean, but they did very differently on the test. Especially Group B is significantly different than Group A and Group C. So once again, in statistics, things aren't always as simple as you would like them to be. There's no right answer, by the way, to this question, which group performed the best. It would be a matter of opinion, you know, what you value. Do you value 4 doing really well and then just not worry about that other one, or do you value consistency? That's a personal decision. Let's talk about this PowerPoint. The 2 words that I thought, if you made up your own study guide for 3.2, you may have not had on there. Those were the 2 I was concerned about. In 3.1, there were 2 bold-faced terminology or terms. One was inferential statistics and one was descriptive statistics. Did you happen to have those on there? I thought you would, because they were in bold-faced type, but I just want to be really fair to everybody. Descriptive statistics describe a characteristic of a sample or a population. Some descriptive statistics are mean, median, and mode, which you're probably very familiar with. But descriptive statistics are just describing the population or the sample, not using those descriptions to make any inferences or any generalizations. Inferential statistics, coming up in Chapter 5 very shortly, we're going to take those descriptive statistics like mean and use them to make generalizations or predictions about a population. So that's the difference between descriptive statistics and inferential statistics. 3.2 is measures of center, and there are different ways to get at the heart of data and determine the overall measure of how a group did. I like this cartoon. What is an average? My average student's doing great. Half my class thinks 2 plus 2 is 3, and the other half thinks 2 plus 2 is 5. Well, if you average this wrong answer with that wrong answer, you actually get the right answer. So that's one way of looking at it. I wouldn't feel so good about that. A measure of center is just the value at the center or the middle of a data set, and the one that you're probably most familiar with is the arithmetic mean, or most often I'll just say mean. It's the measure of center obtained by adding the values and dividing by the total number of values. It's what most people call an average. Every once in a while, probably more than I should, I'll accidentally talk about the average, and when I do, I'm talking about mean, but average is not a statistical word, and mean is. These are some symbols that we're going to be seeing in a lot of formulas this semester, and you really need to know what they stand for. Even though your calculator is going to do almost all of the calculations for you, I can only really think of 2 formulas all semester that your calculator doesn't have a button for, but still, I want you to understand what your calculator's doing. And to understand that, you need to know these symbols. This is the Greek letter capital sigma, and it means the sum of. So whenever you see that capital sigma, some values are being added up. X is the variable used to represent the individual data values. Sometimes you'll see X with subscripts. X with a subscript of 1 is the first data value. X with a subscript of 2 is the second data value, and so on. Little n for the whole rest of the semester is going to be the number of data values in a sample, and capital N is the number of data values in the population. So you'll see those symbols in the formulas coming up. For example, X bar is the mean of a set of sample values, and another Greek letter for you, mu is the mean of a population. To get a mean of a sample, you just add up, that's what the Greek letter sigma means, you add up all the data values and you divide by the number of values in the sample. So sigma x over n is saying what you already knew was the right way to find the mean. Just add them up and divide by the number in the sample. The population mean, mu, you add up all the x values and divide by capital N, which is the number in the population, not the number in the sample. It's going to be important all semester that you know when you're talking about a sample and when you're talking about a population and which symbols go with which. The advantages of using a mean is that means of samples drawn from the same population don't vary as much as other measures of center, and they take every data value into account. If I'm finding the mean weight of U.S. citizens, and I use sample sizes of 100, randomly chosen sample sizes of 100, and find the mean of each sample, then if indeed I have done a good job of randomly choosing my sample people, then no matter how many different samples I take, if they're simple random samples, the mean will be about the same for all of them. It doesn't vary very much. Disadvantage is that it's sensitive to every data value. One extreme value can affect it dramatically. That means it's not a resistant measure of center. It's not resistant to those outliers. The group B, was it, that 4 people made 85 and 1 person made a 10? That 10 was an extreme outlier, and it pulled the whole class average down 15 points. So mean is very sensitive to outliers, and that's something that you have to watch out for and maybe compensate for in some way. The median is the middle value when you put the original data values in order. It could be increasing or decreasing. It doesn't matter. You just have to put them in order and then pick the middle one. If there's an odd number of data values, then there'll be an exact middle one. If there's an even number of data values, there's not going to be an exact middle one, so you have to average the middle two. Just choose the middle two, add them, and divide by 2. The symbol for median is pronounced X tilde. That's what the little squiggle on the keyboard is. And it's not affected by an extreme value. It is a resistant measure of center. If I took those group B scores, 4 85s and a 10, put them in order, then the exact middle one is 85. And in that case, it's a better reflection of how that class did than the mean actually was. Find the median. Already said that. Put them in order. If there are an odd number of data values, it's the exact middle one. If there's an even number of data values, then just find the mean of the middle two. For example, that set of data has 12 values. Since 12 is even, there's not an exact middle one. Are they put in order? Let me think. Oh, this must have been the original datas, and this is data values, and this is the same data values put in order from lowest to highest. Since there's an even number, 6, then the median would be the average of 0.73 and 1.1. The median's 0.915. However, if you have a group of 7 data values and you put them in order, then there is an exact middle one, and the median of that set is 0.73. All right, we're finally going to get to use a button on the calculator, and you need your calculator, your TI-84 in class with you every day from now on. I did not know till last semester that TI-84 or Texas Instruments periodically has updates for the TI-84, just like Windows or Microsoft periodically have updates. I didn't know that. I thought all TI-84s are the same. Every once in a while, you might have a calculator with a older operating system than somebody else's, and there'll be just a little bit of difference in how you type in the information. You'll know right away. You know, if your calculator doesn't look just like whatever I'm showing on the screen, then wave at me. I'll come back and show you what to do on your calculator, but there's not a very big difference between the operating systems. All right. If I had, for example, 30 data values and I had to find the mean, I have a hard time typing in 30 numbers, adding them and dividing by 30 without making a mistake typing them in. And there's no way to look back and see what your 30 values were. I mean, I just would probably try it 3 times, and if I got the same answer all 3 times, assume it's right. But your calculator can actually find these measures of center for you. This is just 8 NCAA football coach salaries given in USA Today, and we want to find the mean and the median. Well, since it's just 8, we don't need a special calculator for that. We could just add them up and divide by 8. But I want to go ahead and show you how to enter data into the statistics function of your calculator. So, button by button, here's what you push. Enter the data from the Edit submenu. Press Stat and then Enter to choose number 1, Edit. And the cool thing about technology is that I can actually show you exactly what I'm punching on my calculator. Ooh, or my half calculator. Come on. There it is. All right. Your stat key is the third key on the second row. Right here. And when you enter that stat key, you have 5 choices. Let me go ahead. I don't have this typed in the slide, but let's go ahead and clear out any lists that folks may have used last year or last time someone had that calculator. Number 5 says setup editor. Go ahead and enter 5 and then just enter. And now if any of your lists were deleted by somebody else last semester, they're back now. All right, now let's go to stat and number 1, edit. Since edit's already highlighted, I can either enter the number 1 or I can just hit the enter button. And those are the last 2 lists that I typed into the calculator last semester. I want to clear those lists. To clear those lists, all you have to do is move the cursor up to the list name and then this clear button. So move the cursor with the up, down, left, right arrows and clear and enter. And that list is clear. Okay. Move the cursor up 1. Oh, you have to move it up to the name of the list. Yep, and then enter. Yep. Do the same thing with list 2. No, you've cleared out all the numbers. Let me clear out my second list, and then we will enter those coaches' salaries. All right. Is everybody, or let me ask it this way. Is anyone not starting with a clear list 1 and a clear list 2? All you have to do is wave at me, and I'll come see what's going on. All right. Let's enter those 8 coaches' salaries. The calculator's already ready for that data, so just enter the $150,000 for the first coach and enter. $300,000. Okay, let me come look. All right, do go to, and it'll tell you, well, that's interesting. It looked okay. Let's go back over here to list. Okay. Try it now. I'm not sure what was going on, but I think it's going to work now. Yep. Yes. Yes, and then when you hit enter, it'll pop it up in the table. So enter the 150,000, enter, and it'll pop up there. Then the 350,000. Oh, I left off. See, I made a mistake. I'll play like I made it on purpose. I need to go back. I left off the 147 right there. Just move the cursor up 1 and retype it. $150,000, $300,000, $350,000, $147,000, $232,000, $425,000. Ooh. What just happened on my calculator when I entered that 1,231,421? What the heck happened right there? And what is that? Anybody have an idea? That is the exponent of the 10 in scientific notation. Remember, scientific notation is a number between 1 and 10 times 10 to a power You just move the decimal to the left or the right based on whether the exponent's positive or negative. Now, this is something that's going to happen over and over this semester. And last semester, I had people still asking me in the middle of the semester, what's that E? So if you need to make a note somewhere, go ahead and make a note. Whenever your calculator gives you that E, it's just writing your answer in scientific notation. If I see 1, 2, 3, E6, the calculator still knows that there's decimals after that 6. The calculator's still storing those digits after the 6. It's just not showing them to me. But if I move that decimal 6 places to the right, I would get back this original data value. Anytime you get an E, that's just your calculator's way of changing a really big number or a really small number to scientific notation. And it is keeping up with the digits that it's not showing you. What about the 810,000? And the 229,000. You don't have to click save to save that data. If you just exit it, it will be there tomorrow or next time you turn on your calculator. Let's see. To exit the stat editor, press second and quit. Quit is the middle button on the top row, right over the word mode. Anything in blue, you're going to have to press second to get to it. And now I've exited the stat editor, but the calculator has saved those values for me. Now I want the calculator to find those measures of center for me, at least the mean and the median. Something crazy going on?
Yeah, I hit the mode quit and it gave me this.
It's second and then quit.
Oh.
Yeah, just clear that and then second and quit. I know that it would be difficult, all these processes we're going to do, it would be difficult to remember them all just the one time I say it in class. But don't forget when you're doing your homework that I've typed, anytime you do something new on the calculator, I've typed button for button exactly what you enter. TI-83 will store up to 6 lists if you wish to clear any particular list. We've already done that. Just move the cursor up to the list name, press clear, and then enter. Where am I? Right there. All right. Here's how we get the calculator to calculate the mean, the median, and some other stuff for us. To display the list math menu, the list of the things, the math that the calculator will do with your list, press second and list is right over your stat button in blue, right here. So second and list. And then you have to tell the calculator what list you want it to use to calculate the mean, median, mode, whatever else you want. So we saved our data in list 1. That's already highlighted. So all I have to do is enter. You know what? I think I pointed at list math and then I didn't do it on my calculator. Let me try again. Second list, and then move the cursor over to math. And choose what you want your calculator to calculate for you. It'll calculate the minimum element of a list. It'll calculate the maximum element of a list, the mean of a list, the median of a list, or the sum of a list. If you want the calculator to give you the mean, then that's number 3. You can either move the cursor down to mean, or you can just enter the number 3. And now you have to tell the calculator what list you want to use. Right over the number button 1 in blue, you have list 1. So second and the number 1 will tell the calculator, find me the mean of list 1. And then enter. And the mean NCAA football coach salary from the given sample looks like, if we round it to the nearest dollar, $457,874. Now, anybody not getting that, wave at me. It's just going to take a little bit of practice. Right there, second and list 1. Okay. I promise this is going to be okay after. Oh, okay, I see what you did. Second list, and then over to math, and 3, and then don't type anything. List 1 right there, second and list 1. You're telling the, yeah, not 3, but go ahead. Mm-hmm. Okay, you have asked it to find the minimum, and that's not actually what you want it to find right now. If you say second list, go over to math and say, I want the mean, enter 3 for me. Okay, or move the cursor down. And now second and list 1. Nope. You can close the parenthesis, but I don't think you have to. 457. You're welcome. Any questions about that? So the mean salary, football coach salary from the given sample is about $457,874. Now, the math menu will also calculate the median for us. Again, if we just have 8 data values, you could put those in order and pick the middle one, or even average the middle 2 faster than you could type all of that into Stat Editor. So I wouldn't use these functions if I only had 8 data values. But if I had 20 data values and I wanted to calculate several different measures of center, I'd rather just type them in a list and then let the calculator find each of these things for me. Now I'm ready to find the median. So go back to second and list. Move the cursor over to math again. And median is number 4. Either move the cursor down to 4 or just enter the number 4 and don't hit the enter button yet like I did. And then tell the calculator what list you want to find the median of, which is my list 1 again. Wow. The median of those 8 coaches' salaries is over 100,000 less than the mean. The median is only $325,074. Which do you think is a better representation of what NCAA coaches make? The 457,000 or the 325,000? Why do you say that? I would agree with you, but tell me why. Well, it's just 8 randomly chosen coaches. We don't know what they do. Yeah, we don't know anything about their responsibilities. Just 8 randomly chosen coaches, and their mean salary is about $458,000, but the median is only $325,000. Guess who that is? Bama fans. That's Nick Saban, the only man I'd leave my husband for. And he knows that. And Kate Hudson's the only woman he would leave me for. So I don't think either one of us is in danger of being left. Yeah, remember that resistant measure of center? If you have one outlier, one value that's drastically different than the others, that will drastically affect or can drastically affect the mean, but it's not going to affect the median. Let's go back and look at those original data values right here. Poor little coach making $150,000. The others are in the 200,000 and 300,000 range. Oh, well, there is one other person doing pretty well here, 810,000. But still, this coach is making almost 10 times as much as this coach and 4 times as much as that coach. So this coach is getting paid really, really well. Maybe it's because he's won 2 national championships in a row. I'm sorry if you don't like Alabama. I'm from Alabama. I'm not a traitor. I'm from Alabama, so it's okay. Let's see. What else do we need to do? We talked about that. Let's talk about mode. That's what's up next. The mode is the value that occurs with the greatest frequency. Sometimes a data set has just one mode. Sometimes it has no mode. Sometimes it has more than one mode. Bimodal means there are exactly 2 data values that occur with the greatest frequency. If you had $2 million salaries and all of the other salaries were different, 300,000, 400,000, 700,000, then that would be a bimodal set of data because that $1 million salary occurred twice, and twice was more than any of the other salaries occurred. So that's bimodal, 2 modes. Multimodal is just more than 2 data values occur with the same greatest frequency, and no mode is when none of the values are repeated more than once. Now, if there were 2 of everything, that would be multimodal. If there's 1 of everything, that would be no mode. Mode is the only measure of central tendency that can be used with nominal data. For example, if we listed all the makes of cars in the U.S. and then tallied up how many Fords there were, how many Chevrolets there were, we could find the mode of that data, but it doesn't make sense to average Ford and Chevrolet and Hyundai and Toyota. So you couldn't find the mean of those categories. You couldn't find the median of those categories, but you could still find the mode of those categories. Here are 3 different data sets. Data set A, let's see. All of the data values only occur once, except for the 1.1 occurs twice. So that's an example of a data set that only has 1 mode, and it's 1.1. Data set B, there are 327s, 355s, 288s, and 199. The 2 numbers with the highest frequency are 27 and 55, so that data set is bimodal. 27 and 55 are both modes. And then data set C, no value is repeated more than once, so that data set has no mode. All right, one more measure of center is the mid-range. That is the value midway between the maximum and minimum values of the original data set. If I had, go back to that set of data where 4 people made 85 and 1 made 10. I mean, I feel like that class did pretty well except for the 1 knucklehead. But if I just averaged the highest score, 85, and the lowest score, 10, then the class I would say the class mid-range is what would it, about 47.5, I think, 47.5. That looks like the class did very poorly. So mid-range, you can use it if you have to. If you only know the highest score and the lowest score, you can use mid-range, but it's probably the least good measure of center because it is extremely susceptible to outliers. That 110 skewed the mid-range very, very much. Mid-range is extremely sensitive to extremes, but it is very easy to compute. My personal feeling on that is, yes, it's very easy, but it's worthless. So why even give it a name? The only time I would use mid-range is when the highest and lowest values are the only two that I'm given. Throughout the book, you will see round-off rules. The first time I taught this class, I was thinking every darn thing has a different round-off rule. You round off some to the nearest tenth, some to the nearest hundredth, some to the nearest thousandth, some to the nearest whole number, and I was afraid I was going to have to memorize all those round-off rules. You don't have to. On the homework and on the test, it'll tell you what to round to. The round-off rule for measures of center is carry one more decimal place than that is present in the original data set. So if everything in the original data set is rounded to the nearest tenth, you would give the mean to the nearest hundredth. One decimal place more precise than the original data, but again, it'll tell you that in the homework and on the test. All right. You didn't even really need me to talk about that. Yes, I spent, Lord have mercy. What time did we start? 8:30? 40 minutes talking about stuff that was pretty easy. There are two things that I was not going to have on the reading quiz, and I'm not going to go back and add them to the reading quiz, but two things that we do need to do examples of. One is the mean of a frequency distribution, and the other is a weighted mean. For example, remember frequency distribution? I have different classes. For letter grades, it may be 90 to 100, 80 to 89, 70 to 79. And then I just have the frequency of data values that occur in each class. Well, what if I want to find I don't have the original data. All I have is the frequency distribution, and I want to find the mean of that frequency distribution. Well, here are those symbols again. You multiply each frequency times, each data value times its frequency. If there are 10 50s, then you multiply 10 times 50. You do that for each of the data values and add up all of those products. Then you divide by the sum of all the frequencies. Remember when we had a frequency distribution? We could add up all the frequencies, and that's the total number of original values. That's all this is, divide by the total number of values. This formula makes sense when you think about it. If I had, say, 10 90s, 8 80s, and 7 70s, I wouldn't want to have to add all of those values individually. So I would just say 10 90s is 900, 7 80s is 560, and whatever else I said, and then divide by that total number rather than having to add all of the data values individually. One thing to notice here, it says use the class midpoint for the variable. So for example, I have a problem that we can actually work out. Calculate the mean from this frequency distribution. We have 5 classes. First class is 50 to 69, second class 70 to 89, and so on. I need to find the class midpoint or the midpoint of each class, and use that as the quote average score or whatever this is in that class. So the class midpoint of the first class, 50 to 69, how do you find class midpoint? Yeah, just add them and divide by 2. 50 and 69 is 119, which is divided by 2 is 59.5. That's almost halfway between 50 and 70. Halfway between 50 and 70 would be 60, so that's reasonable. And I could keep doing that for the other 4 classes, or I could notice that my class width is what? 20, and just add 20 to get the next class midpoint. 79.5, 99.5, 119.5, and 129.5. Those are my class midpoints. What did I do? Oh, yep, thank you. 139.5 for that last class midpoint. Now that first class had a frequency of 24. I don't know, again, if these are scores, some type of scores. I don't know that I had 24 people who scored 59.5. I just know I have 24 people that scored between 50 and 59 or 69, and 59.5 is the best thing to use for, I don't know how to finish that sentence. I started a sentence that didn't make sense. 59.5 is the class midpoint, so just use it and say, I had 24 people make 59.5. Somebody multiply those for me. Even? Yeah, it would be even. Okay. What about 79.5 times 228? 1826? 18,126. Do I have a second on that? Okay. Third class, what's the midpoint times the frequency? Do I have a second? All right. Fourth class. Second. Okay. And last class. 3,627. Okay. I need to find out how many data values. Oh, these are IQ scores. Why didn't I look at the title to begin with? I don't know. IQ scores of 1,000 adults. If I had read the title, then I wouldn't have had to add these up, which is what I was fixing to do to find the total number of data values, add the 24, 28, or 228, 490, 232, and 26. But they better add up to 1,000 since that's what the title said. What is the sum of these products? Has anyone added this up yet? Anybody second that? All right. All opposed, say nay. We've already talked about IQ scores being normally distributed. What is the normal, if you want to use that, IQ or average IQ of all adults? Well, technically it's supposed to be right at 100. Is 99.66 what this one turns out to be? And that sample mean is very close to the actual population mean. This sample mean is 99,660 divided by 1,000, which is 99.6. Again, X bar stands for what? Mean of what? We have a sample mean and we have a population mean. Which one is X bar? Yeah, that's the sample mean. .6 just describes one measure of center of the sample. Now, and that's descriptive statistics. Starting in chapter 5, we will learn how to take the mean of a sample and use it to construct a confidence interval for the mean of a population. We might say, I want a 90% confidence interval. That means a range which I'm 90% confident the true population mean lies within. That's getting a little bit ahead of myself. All right. One other example that I think will be particularly useful to you is the weighted mean. Some folks don't know how to calculate their GPA. What hurts your GPA more, an F in biology or an F in fitness walking? Or are they the same? F in biology, why? It's a 4-hour course where fitness walking's only a 1-hour course. So your GPA is a weighted mean because your grade in each course is weighted with the number of course hours of each course. You multiply the weight times each data value and divide by the total weight. Your average for this course at the end of the semester is also a weighted average because your tests count way more than your homework or your study guide. I will multiply, what do I have in the syllabus? 80, is it 80, 10, and 10 or 85? I think it's, let's say it's 80, 10, and 10, and I'll look it up before I actually calculate your grade. But if the tests count 80% of your grade, and let's say you have a test average of 90, then I'm going to multiply 0.8 times 90. And I'll do that for your homework and for your study guide. And I have set all those weights up to equal 100. So I just divide by 100. But in some other situation, the weights may not add up to 100. Let's calculate the GPA for this student. 80, 15, and 5. Yeah, I don't want the study guide to count as much as your homework. That's good. But it's different for each of my classes, so I have to look it up when I need to. All right, this student had a pretty good load this semester. Took Comp 1, Biology 1, Statistics, American History, and PE for a total of how many credit hours? Yeah, 14 credit hours. Good, solid load. Oh gosh, this was probably me. Well, I made an E in all my maths. E? We didn't have E's. I made an A in all my maths, A in all my Englishes, A's in all my histories. Came darn close to failing tennis because I am so uncoordinated. My husband likes to throw things at my head just to watch me go right after they smacked me in the forehead. Actually, I made a B in tennis because of, thank God for written test. I can memorize and spew back anything you want. I just can't hit the ball. And broke my pinky toe doing it. I'm so glad I only had to have 2 PEs. All right, let's calculate this person's GPA. In college, an A is 4 quality points. I've got this at the top for you. An A is 4 quality points. A C is 2 quality points. An A is 4, a B is 3, and F is 0. So I need to multiply each credit hour times the number of points that you got for your letter grade in that class. I earned 12 quality points for my English class. 4 times 2 is 8 quality points for biology. 3 times 4 is 12 quality points for statistics. 3 times 3 is 9 quality points for history, and 0 credit points or quality points for PE. How many quality points does this person make this semester? 32, 41, I think. This person's GPA is just the sum of all the quality points divided by the number of credit hours you take. So 41 divided by 14, this person's GPA to the nearest, say, 2 decimal places is what? So you second that? 2.93. A little bit low for the lottery scholarship, but plenty high enough to keep you out of trouble with Pell Grant. GPA of 2.93, do just a little bit better next semester, and the lottery scholarship will be okay again. All right. Any questions about GPA as a weighted average? So we've done that. Best measure of center. Well, each measure of center has its advantages and disadvantages. This chart shows you how to find the mean, how to find the median, how to find the mode in the mid-range. And then below that gives you the advantages and disadvantages of each. The mean is good because it samples from the same population have very similar means. But the disadvantage is it's very sensitive to outliers. A median is good if there are some extreme values because it's less sensitive to the outliers. And the mode is good for nominal levels of measurement. That's pretty much the only time I would use mode is if I have nominal data and I can't add them up and divide by how many there are. And then the mid-range, only time I'd use it is when all I was given was the highest value and the lowest value. So my best measure of center would just be to average those two, but I wouldn't bet any money on it. It may not be a very good reflection of the actual measure of center for that data. All right. End on a cartoon. In retrospect, it was clear why Jack was bragging about the mean height of his beanstalks rather than the median. Somebody explain that to me. I don't get it. How would he find the mean height of his beanstalks? How do you find the mean? No. Mean is just measure each of the beanstalks, add up all the heights, divide by the total number of beanstalks. That would be the mean height of the beanstalks. How do you find the median height of the beanstalks? All right, I'm going to make you explain this cartoon for your reading quiz. What did you say? All right, if he put all these beanstalks in order, then the middle one is going to be one of these guys. But if he finds the height of all the beanstalks with that one huge beanstalk, adds them all up, that outlier is drastically going to skew the mean where it wouldn't affect the median at all. I don't know. Cartoon may not be good if you have to explain it, but the more you know in statistics, the funnier these cartoons get. There are two more words. We've used the word symmetric to describe data. For example, when we said data was normally distributed, it reaches a high point, and then the right-hand side tapers off roughly a mirror image of the left-hand side. That is symmetric data. And if the data is symmetric, then, if it reaches a high point and the left side and the right side are symmetric, then you say this is a symmetric data set or a normal distribution. Skewed is just when it's not symmetric left and right, when it's leaning more one way than the other. And when you talk about skewness, you can talk about data which is skewed to the left or skewed to the right. These definitions are straight out of the book. It's not necessarily the easiest way for me to determine whether something is skewed to the left or skewed to the right. Let's talk about the book's way of telling and then my way. Skewed to the left, also called negatively skewed, have a longer left tail. Again, if you draw the normal distribution, the left and right sides are mirror images of each other, but skewed to the left would have a longer tail on the left than normal would, and the mean and the median are to the left of the mode. Skewed to the right has a longer right tail, and the mean and the median are to the right of the mode. Maybe you totally get that and are fine with it, but these next two examples, let me tell you how I think about it. Here are pictures of a data set that is symmetric, and if it's symmetric, the mean, the median, and the mode are all the same. This graph comes from some data that is skewed to the left. Yes, it does have a longer left tail, and the mean and the median are to the left of the mode, and then that's a picture of skewed to the right or positively skewed. But here come the examples. Let's talk about these examples, and then if you still have a question, we'll go back to it. This is a better way for me to think of, is it positively skewed or negatively skewed? If the New York Yankees baseball team of 2006 had a mean salary of $7 million, but the mode was closer to $3 million, how could that even happen? How could the mean be 7 and the mode only be 3? This is Nick Saban coaching the New York Yankees, or playing on the New York Yankees. One really high salary dragged the mean up. When I'm thinking drag the mean up, that's positively skewed or skewed to the right. That's the easiest way for me to think of it. If one really high value, one high outlier is raising the mean, then that's positively skewed. And in the second example, I have scores on a math exam. How could the mean be 68, but the mode, which is the greatest frequency, more people made 75s on the test than anything else? How could these two be different? How could the mean be lower than what most people made? Somebody made a really low grade. Even though most folks made 75, that really low grade dragged the mean down. And whenever I think drag down, I think that's negatively skewed or skewed to the left. Now, Melissa, did that answer your question, or do you still have a question?
It's a question.
Okay, tell me.
So the means you always find in the middle of the hump?
Let me go back to this.
Do it in the middle of the diagram. Or do we not need to worry about
It would be much more clear to you if we actually had the data set here. If we had a data set and you put the mean, the median, and the mode on there, you would see whether it's in the middle or to the right or to the left. It's hard to see without being given the original data set. But this just illustrates the greatest frequency being higher than the mean or the median. And this is when the greatest frequency is lower than the mean or the median. You're welcome. All right, so we talked about different measures of center, mean from a frequency distribution, weighted mean, best measures of center, and skewness. And I'm going to run to my office and upload that 3.2 template. If you've already made your own, don't start over and just to write on my paper. It's not necessary. If you haven't already made your own, then print that off and or save it and type in it, whatever you did last time. Y'all did a really good job on your study guides last time. And then the homework is